Hi friends, and welcome to this lesson. In the previous lesson, we looked at vectors in 2D. If you missed that one, please go start there and come back here. Now we're going to continue with Newton's laws. Right, so here's a question. A force of 30 Newton is applied to a box, moving it to the right at a constant velocity along a rough surface. Okay, that was a statement. The questions now. Determine, is the object accelerating? All right, I'll first make you memorize this because it will never change. Then I'm going to explain why it is so. Once they say constant velocity in the statement, once they tell you that the velocity is constant, you must always know the acceleration will be zero. All right, it will be zero. So in other words, no acceleration. No acceleration. There will be zero acceleration. Why? Okay. Acceleration is change in velocity over change in time. Now think about it. Constant velocity means velocity not changing. Okay? Velocity is not changing. What does that mean? It means the final velocity is equals to the initial velocity. Since the velocity is not changing, what you started with is going to be the same as what you are currently having or what you're going to end with. So the final velocity equals to the initial velocity. If the final velocity was 3 meters per second, also the initial velocity will be 3 meters per second. Why? Constant velocity, no change, constant, no change. So what will that do to this formula? Since change in velocity is final velocity minus initial velocity, what's going to happen now is we're going to say 3, since the final velocity is 3 there, minus 3. The initial velocity is also 3. What do you get? 3 minus 3 is 0 over change in time. If you take 0 and divide by anything, you're going to get a 0. That is why the acceleration will be 0 if the velocity is constant. All right? You can just memorize because it won't change. Once you read constant velocity, just say, aha, go assign the acceleration to be 0. And that's it. That's how we answer that particular question. Okay? So the magnitude and the direction of the kinetic frictional force, they want us to determine the magnitude and the direction of the frictional force. That's the question number 2 that I'm reading now. All right. In order to answer that, you need to first go identify where your frictional force is acting. Is it horizontal? Is it vertical? Is it inclined at an angle? You need to first go find out where your frictional force is. So we are moving the object to the right. Ne? And friction is the force that opposes motion. So if the object is going to the right, frictional force will go to the left. It opposes motion all the time. So you're going to have frictional force here going to the left. That is our kinetic friction. I say kinetic because it is the frictional force that exists because of movement. Okay? There is also another one called static friction. We'll talk about that in the future videos. So we have our frictional force now identified. It is going to the left, opposing the motion, since we are moving the object to the right, as per the statement there. So we are moving the object to the right, meaning frictional force will oppose and go to the left. Building from the first lesson, we said we can only sum forces directly if they are parallel. So we are only interested in the parallel forces here. So the applied force, this one, and the frictional force, they can interact directly. But the weight, the Fg that is happening there, and the other forces that are vertical, that I'm going to talk about in a minute, we are not going to look at them. Why? They are perpendicular to that frictional force. So we want only the forces that are parallel. So the horizontal forces, we're going to sum them together. Let's do that. Remember, when we sum forces, according to the first lesson, we have to choose direction first. I will always advise you, take the direction of motion as positive. Our object is going to the right, so let's assign right as positive. Meaning anything going to the left is going to be negative. Our frictional force is going to be negative in the formula. Our applied force here is going to be positive since it's going to the right. The frictional force is opposing our positive direction, then it's going to be negative. Let's go make a formula. Let's start with the applied force. So applied force is positive. Frictional force, negative, remember, because it's opposing our positive direction. So, according to Newton's second law, it says F net equals to ma. So, when you sum your forces, you must get mass multiplied by acceleration. We've already answered that the acceleration is 0. So it makes this whole, the right-hand side to be 0, because when you take the mass multiplied by 0, you're going to get 0. Again, you can memorize. When you have constant velocity, F net equals to 0. F net equals to 0. When you have constant velocity, F net is 0. You can just memorize. It will always be like that. So now, we know that when we sum the forces, we are supposed to get F net. When we sum the forces, all our horizontal forces, we're supposed to get the F net in the horizontal. They may be specific. Horizontal. The vertical forces, they also have their own resultant force. And of course, the overall resultant force will be 0 again because there's no acceleration here. All right. Now, F net is 0. We've spoken about that. We will go and say applied force minus frictional force is 0. You can memorize. When there's constant velocity, F net is 0. Please remember that. I will emphasize it because it's so important. Okay. Now, what do we have? Our F net is given to us as 30. No, our applied force, sorry, is given to us as 30. We are looking for that kinetic friction. We can transpose the Fk because it's negative so that it can be positive. We have 30 equals to Fk. So the value of our frictional force is going to be 30 Newton going to the left. All right. Fk. I know some learners don't like it when you write stuff like this, so let me just write it in a normal way. So Fk equals to 30 Newton to the left. It doesn't really matter where the Fk is, whether it's on the left side or right hand side. But there it is. That is the value. The magnitude is 30. The direction is to the left. I hope you understood everything there. If you feel I was too fast, please just go back, watch this again, and make some notes. But the takeaway in the specific problem is that constant velocity means 0 acceleration, hence 0 F net. F net is the sum of all the forces in whatever direction you are looking at. Here we're working with horizontal forces, so when we sum all our horizontal forces, we must get 0 because that's the F net. Great. The magnitude, or number 3, let's go determine the magnitude and direction of the normal force. Like we did in the previous question, we must go and identify where the normal force is acting. Is it horizontal? Is it vertical? Let's go and find out. Normal force. What is normal force? Normal force is a force that exists because of the plane. Okay? So it is always perpendicular to the plane. Okay? Here's our plane. The box is resting or is moving along that plane. It's not resting. It's moving along that plane, that horizontal plane there. So the normal force will always act perpendicularly there to the plane. It will always form 90 degrees to the plane. If our surface was like that, the surface was like that and the object was sitting like that, the normal force was going to be acting this way. It's always perpendicular to the surface. All right, there it is. Always 90 degrees to the surface. If your surface was like this, vertical, it means your normal force was going to be like that, perpendicular to the. I hope you get the idea. You always look at the surface. I know there's a misconception about the normal force must always be collinear with the gravitational force. No, it's not true. When you want to assign your normal force properly, look at the surface and draw a force that is perpendicular to the surface. So there is your normal force. So since it's perpendicular to the surface, it means it's vertical. Now we are interested in the vertical forces because the force we are looking at is vertical. We're going to ignore the horizontal forces for this particular problem. We're going to only concentrate on our vertical forces. Do we have another vertical force? Yes, we do. There is the gravitational force because it's always acting downwards. Fg, the force due to gravity. So that when a gravitational acceleration acts on that mass of 5 kg, we're going to have weight, or the gravitational force, always acting downwards. Always acting downwards. This one is not dependent on the surface. It's always acting downwards. It has no regard to the surface. It acts downwards. What I'm saying is, even if the surface was inclined and the block was resting there, the gravitational force will be going downwards, vertically downwards. All right, vertically downwards, even though the normal force will be going perpendicular to the surface. I hope you get the difference. Gravity goes down, regardless of how the surface is looking. Great. So those are the two forces that we are interested in. Then normal force and the gravitational force, because they are both vertical. We want to deal with forces that are parallel. So let's go on and make a formula along the vertical. So choose direction first. I'm going to take upwards as positive. If upwards is positive, it means the normal force is going to be positive since it's going up. So we have positive N, and the gravitational force is going to be negative since it's going down. It's opposing my positive direction. So we're going to have negative Fg equals to, do we have any movement? Is there any acceleration along that vertical direction we are talking about? Remember, we said we are looking at the vertical forces. Do we have any movement there? Is there acceleration? No, the block is not flying up or rising up, and it's not sinking downwards. Okay, it's just on the surface. It's moving along the surface. It's not going up, it's not going down. So if there's no movement, we're going to equate that to 0 because there's no acceleration again. I see? So F net in the vertical is also 0. Right? If there was acceleration, we were going to equate it to MA again. But now, 0 acceleration, it means 0 net force. Great. Let's go. We are looking for U normal force. We're going to leave you there. And then Fg is mass multiplied by gravity. There you are. We move on. What is the mass? It is given to us as 5. What is G? G is the gravitational acceleration. It's a constant. We're going to use it as 9.8 meters per second squared. All right? We're going to take it as 9.8. It's a constant. It will be given to you also in the formula sheet. So you're going to have equals to 0. Now go on and multiply the two. 5 multiplied by 9.8 is going to be 49. Then equals to 0. We're going to transpose let's transpose that 49. When it goes the other side, since it's negative, it's going to become positive. So we have 49 newtons. Where is the normal force going? It's going upwards. And that's how you get the value and the magnitude of the normal force. Here the magnitude is 49, here the direction is upwards. And that's it. Thank you very much for sticking with me. I know it was a bit long, but let's meet again in the next lesson. That's lesson 3. We are going to be looking at forces that are acting at an angle. We're going to have the applied force now at an angle. I'll see you there. Bye.